G'day smart people, my name's Dylan Dance. I'm a physicist from the land down under. Today we're going to watch some Futurama, so if you haven't already, please subscribe. Let's get into it.
Excuse me, I missed a few lectures. What subject is this?
Ancient Egyptian algebra.
Oh, what a nightmare!
There is actually such a thing as ancient Egyptian algebra, and you can betcha they used it to build all those pyramids. So the Earth stopped rotating.
And action.
So this would actually happen if the Earth suddenly stopped rotating. Its entire atmosphere would still be in motion at 1100 miles per hour at the equator. So anything not attached to bedrock would probably go flying into the atmosphere and everything would probably be destroyed. So that's pretty much what would happen, except for the actual continents moving. I don't know about that. But you're definitely going to get everything launched into the atmosphere and just destroyed. And then on top of that, Earth's magnetic field would crumble because the fact that Earth's rotating is actually what generates this magnetic field, because you have liquid metals in the Earth's core. Moving electrons generates a magnetic field. And so that's what generates Earth's magnetic field. And Earth's magnetic field protects us from all the cosmic rays and all sorts of other stuff. Without that protection, we're pretty stuffed. A huge thanks to Skillshare for sponsoring this video. There's a link in my description. The first 1,000 people to use this link will get a 1-month free trial of Skillshare. This channel is all about curiosity, discovery, and learning fun new things in a cool way. And Skillshare is just another place where you can take your curiosity even further. Skillshare is an online learning community with thousands of inspiring classes for creators. You can explore new skills, deepen existing passions, and get lost in creativity. There are classes for all skill levels that'll fit any schedule. If you want to make YouTube videos, if you want to make anime, if you want to learn how to do physics or math, there's classes for you. It's curated specifically for learning, so that means there's no ads, and they're always launching new premium classes so you can stay focused and follow wherever your creativity takes you. I recently actually took a course called Learn Indie Filmmaking by Olav de Fleur, and it was awesome. Pretty much learn how to make an indie film, which I think is super cool. So make sure you use that link in the description. It helps my channel out a lot. And the first 1,000 people get a 1-month free trial of Skillshare.
I had a good life. What do you say the three of us grab a six-pack and watch the universe end?
Here, here. That's basically what I do every day.
To the end of the universe. So long, Earth.
The stars are receding. Oh, the vast emptiness. The last proton should be decaying about now. The end of the universe.
Well, now what? You guys want to talk?
No thanks.
Second Big Bang. It appears this universe is exactly identical to the old one. We just need to keep going forward in time to the point when we left. Easy, easy. Taking her in for a landing. 1 year to go. 6 months. 30 seconds. And here we... Whoa! We'll have to bring her around again.
Amazing.
This new universe is about 10 feet lower than our old one. Pow! We took care of the time travel paradox.
That was the best thing I think I've ever seen in my life. There's so much that we could talk about, but I know you just want me to keep watching more. So maybe let's just say 1 or 2 things. So if you didn't know, there are some rough ideas for how the universe might end. And basically this show has run with one of the popular ones, the heat death of the universe. And it basically assumes that dark energy is going to continually cause the universe to expand at an increasing rate. And what happens is that at every point within the universe, it will be expanding further away from the other point over there eventually faster than the speed of light. Now you might have heard that nothing can travel faster than the speed of light. And that's true, but that's only true within a vacuum. Space-time itself can do whatever the hell it wants. And you might have heard of inflation, which is a period before the Big Bang where space-time increased in size exponentially well beyond the speed of light. And so what will happen eventually if dark energy keeps increasing and the expansion keeps accelerating? Well, the fabric of space-time at every point will be expanding at a rate faster than the speed of light. So that means that the light leaving this galaxy will never reach this galaxy over here because the space in between is separating them at a faster rate. So these different clusters that aren't close enough for gravity to bring together, they're going to start getting further and further away. So you'll look out at the night sky and you won't be able to see any other galaxies. And eventually you'll be left with only black holes, and even they will eventually evaporate thanks to something called Hawking radiation. At that point, you're not really left with much. And this expansion, if it keeps increasing, well, eventually even particles themselves might not be able to stay together until everything's broken up into the most subatomic particles and you only have things like photons moving around, which we don't even know if they have a size.
Whoa, 15 miles over the speed of light.
That's a violation of the law of Lorentz invariance, baby.
Can't have that.
Erwin Schrodinger, huh? What's in the box,
Father of
Schrodinger?
quantum
A cat, some poison, and a cesium atom.
The cat, is it alive or dead? Alive or dead?
Answer him, fool.
It's a superposition of both states until you open it and collapse the wave function.
You.
There's also a lot of drugs in there.
I'm not going to explain Schrodinger's cat. I'm sure a lot of you know about it, and if you haven't, there's lots of good videos on YouTube. But if you didn't know, Schrodinger actually presented the idea of this cat scenario to make fun of quantum mechanics because he didn't like it. He actually said, "I don't like it, and I'm sorry I ever had anything to do with it," because he was one of the founding fathers of quantum mechanics.
And it's a dead heat. They're checking the electron microscope. A quantum finish.
No fair! You change the outcome by measuring it.
Amazing. So he's actually referring to something called the measurement problem in quantum mechanics, and it has to do with the collapse of the wave function, whether it happens, how it happens. We actually can't see it or observe it whatsoever, and this is pretty much what led to all the different interpretations of quantum mechanics surrounding what and how this collapse, whether it even happens. There are interpretations that suggest it doesn't happen at all. This is still a big open mystery, and we still have no idea as to which interpretation is correct or what's really happening with this collapse. And so, yeah, we really still don't understand quantum mechanics. So just for fun, let's take the Copenhagen interpretation to be correct. So you have these two electrons that are closest to the finish line from both horses, and they're both in orbit around an atom. However, I take that back. They're not really in an orbit around those atoms, because that's the simplistic old model that we use to imagine electrons. What's really going on is that these electrons are actually in an orbital. And what that is like a cloud of probabilities around each atom. So it's actually kind of everywhere in these orbitals at once in a superposition. And then upon measuring the electron and where it is in this orbital, which it's, before measurement, it's in this fuzzy probability cloud, well, then it collapses this probability cloud and the electron appears in one location. So like the doctor or professor said, this orbital will actually be the closest thing to the finish line in both cases. But upon measuring it, well, you might cause the electron to appear back here rather than the orbital, which would actually be closer. So he does have a point, but only if the Copenhagen interpretation is correct, because there are many other ways this situation could turn out. You'd never really get a situation like this in real life because it would just never be possible for it to get that close that you need to look at, the electrons to see who finished first.
I don't understand evolution, and I have to protect my kids from understanding it. We will not give in to the thinkers.
It's pretty much our society today.
infinitesimal fabric of matter itself, laying bare the most fundamental laws of the universe. Shh! I'm trying to listen to a physics lecture. Now to examine some matter. Oh, it's just a log I found in a hole in the bottom of the sea. Now, to penetrate its deepest mysteries. Hey, oh my! There's a frog on a bump on this log that I found in a hole in the bottom of the sea.
And that's the ultimate secret of the universe?
Apparently so. Wait! There's a snail on the tail of the frog on the bump on this log that I found in a hole in the bottom of the sea.
Dear Liza!
The snail itself is composed of cells, molecules, atoms.
Psst, those things don't rhyme.
Things only rhyme below 10 to the -5 angstroms, you dope. Now, ions and pions, muons and gluons, neutrinos, gravitinos, we're closing in on the very smallest particles of matter. For the first time, we are about to observe the fundamental structure of the universe. Such detail, such finely wrought, intricate beauty.
It's like staring into the face of God.
This explains everything, even the Big Bang that created the universe.
Every heavenly body has its own particular scent. Here, I'll point it at Jupiter.
You know where this is going, right?
Hey, as long as you don't make me smell your anus.
There it is.
I don't get it.
I'm sorry, Fry, but astronomers renamed Uranus in 2620 to end that stupid joke once and for all.
Oh, what's it called now?
Eurectum. You people are as loud as you are ignorant. Now get back on your turnip trucks and go home. Did, in fact, evolve from filthy monkey men.
My ancestors were not monkeys. They were orangutan.
Dr. Banjo?
In the fur. And I remind you that evolution is merely a theory, like gravity or the shape of the Earth. Evolution is real. Why has no one found the missing link between modern humans and ancient apes?
We did find it. It's called Homo erectus.
Then you have proven my case, sir. For no one has found the link between apes and this Homo erectus.
Yes, they have. It's called Homo habilis.
Aha! But no one has found the missing link between ape and the so-called Homo habilis.
Yes, they have. It's called Australopithecus africanus.
Oh, I've got you now. Fair enough. But where, then, is the missing link between apes and this Darwinius Macilli? Answer me that, Professor.
Oh, okay, granted that one missing link is still missing. But just because we haven't found it doesn't mean it doesn't exist. I don't want to live on this planet anymore.
Mood. Literally had that exact same argument with someone. Don't do it, guys. It's a waste of time.
Good work, everyone. The mother ship is destroyed.
Thing.
It appears to be the mothership.
Then what did we just blow up?
The Hubble telescope.
I highly doubt the Hubble Space Telescope is still going to be around in 1,000 years, because it's actually just about to be replaced with the James Webb Space Telescope, which is going to be 100 times more powerful. It's hopefully going to launch later this year, or possibly next year, and it's going to see even further beyond, and we're going to get amazing new pictures, and we're going to learn so much about the universe. We should be able to see some incredible stuff from the very early history of our universe. And when we combine the JWST with gravitational lensing, we should be able to possibly even infer stuff or see stuff from the cosmic dawn, which is a period roughly 50 million years after the Big Bang. Gravitational lensing might sound super complicated, but the idea is actually rather simple. So very simply, we know that gravity bends light. So you'd expect to find things called Einstein rings, which use gravitational lensing. So what this is when we look out in a straight line in the universe, we see these big galaxies, right? And then behind these big galaxies are other galaxies that are far more distant. So my head is Earth, and you have this big galaxy in between our line of sight of the further, more distant galaxy. And this big galaxy warps the light coming from the more distant galaxy around it, because light gets curved by big pieces of mass, and it creates something called an Einstein ring. And they look really beautiful. I'll put one up in the corner. And it actually magnifies the more distant galaxy. It magnifies the light, and we're able to see further than anything we'd be able to naturally see with, say, telescopes. So you only get an Einstein ring when that object behind is perfectly in the middle and it curves it in this perfect ring. And what you usually get is just, you know, a fuzzy object that's being magnified and a distorted looking image, because you've got to keep in mind that space-time, the fabric of the cosmos, is curved. And you've got mass everywhere and you've got light, you know, going through it everywhere. So as we take pictures of the cosmos around us, you have all these weird looking objects that have literally been, that are bent. So we just have to literally look around and find these things. And I think the current record is about 30 times magnification that we've achieved using gravitational lensing. Before we end this video, it was my cousin's birthday just the other day. He turned 11 years old and he's just started a YouTube channel. I promised him I would give him a shout out. So help me out, go down there and sub to his channel so I can be his favorite cousin. I'll catch you guys next time.